The basic form of the truncus is y equals 1 over x squared. As with the hyperbola, this implies that x cannot equal to 0 because 1 over 0 is undefined, and also y will not equal to 0 because there's no value of x such that 1 over x will give us a 0 value. Here we see the shape of the truncus. As, um, as we can see from the equation 1 over x squared, regardless of whether x is negative or x is positive, the value of x squared will always be positive. And so that's why our truncus, the values of the truncus is always positive. This point here, like in the hyperbola graph video, is the point x equal to 1, y equals to 1. The shape here of the graph, as we saw before, the horizontal asymptotes and the vertical asymptotes are in the same position. X can't be 0, y can't be 0. The power form of the truncus, y is a over x minus b squared plus c. Let's have a look at what happens as we change the value of a. Again, the changing a will change the width of the graph, and also making a negative will flip the graph upside down. Let's have a look now at the graph when a is 2. Again, from this point here, we have x equal to 1. With b equals 0, we have 2 over 1 squared, which will give us 2. And so as we change the value of a, this point here will be dilated or magnified up and along the y-axis, as we can see here. Let's return a to the value 1, turn off our point down here. As with our other power functions, we'd expect as we change b, we'll see that the graph is translated horizontally left and right along the graph. And once again, we can also see that the value of the vertical asymptote will move along with the value of b. Again, why is this? Because x can never be what the value of b is, because if x was b, we'd get b minus b, which is 0. We'd have 0 on the bottom line here. So we can see that the vertical asymptote moves along with b. Let's set that back to 0. Let's just turn that one off for a minute. Again, our value of c on the end of the equation there does, as we would expect, it moves the graph up and down. It also moves the horizontal asymptote up and down. Again, why is that? If c is 2, remember this can never be 0, so y will never be equal to exactly 2. Returning to our power form, we have y is a over x minus b all squared plus c. Remembering this implies that x can't equal b because we'd have b minus b, which is 0, a over 0 is undefined, and y will never equal to c because this will never equal to 0, so y can never equal exactly c. Our vertical asymptote is at x equals b, our horizontal asymptote at y equal to c. Our domain, remembering our domain is all the x values. X can be any real value at all except for the value b. Our range depends upon whether a is positive or negative. If a is positive, we get all the y values where y will be greater than c. Remember, it never equals c, or the set from, or the range from c to infinity. And if a is less than 0, we'll get a set of values of y such that y is less than c, or the values, or the real values from negative infinity up to, but not including c.